All right, so scholars, we're going to talk about geometric proofs. Now, what type of proofs have we done? Symbolic proofs and what? Algebraic. Geometric proofs start the same way. Now, when do we use proofs? Well, it's when we have theorems. Do you remember the very first day of class I talked to you guys about undefined terms, defined terms, postulates, then theorems? But notice I never defined what a theorem was. Remember, a postulate is a statement we accept as true. Can we prove it? It just always happens. We know it's going to be true. But now we're going to have a theorem. All right, so what is a theorem? Let's see. Any statement. Do this because it will go bad on there. You can prove. What do you mean by prove? Let me put it this way. You have to prove so well, no one can see any gaps in your argument. No gaps can be there. Now, honestly, there's times where I'm going to assume something that we all know it, and I'm going to let you have gaps. We're not in a formal higher level mathematics course, but we're going to do proofs a lot this year. Now, in order to do this, we have to start with some theorems. Now, you guys, you already know this theorem. We just didn't write it down yet. Are you guys ready? All right, the first one's called the linear pair theorem. Guys, what's a linear pair again? They add up to 180. That's not the definition of a linear pair, but that's the result. That's our theorem. Way to steal my thunder. Okay, a linear pair. What type of angles are they? I heard it starts with an A. They have to be adjacent, correct? Oh boy. And their non-common sides form a what? Yeah, opposite rays, exactly. They form a line. They're opposite rays. Good way of describing it either way. They're either opposite rays or they form a line. Oh, aren't those a linear pair? Now, Katie totally stole my thunder because what do we know? And we talked about this. Remember I told you guys this is obvious. You should know this. Well, this is a theorem we're going to use. It says the following. If two angles form a linear pair. Katie told me they added up to 180. Well, if two angles add up to 180, they're called what? Yeah. Then they are supplementary. Now, can I then assume, look at my hypothesis, they're a linear pair, so therefore can I assume they add up to 180? Is that an if-then way of thinking? If a linear pair, then they add up to 180 degrees. Pretty simple, right? Now, every proof, every theorem can be proven. I'm going to give you your first geometric proof, and we're going to prove this theorem. Here's some rules. You can never state the theorem inside the proof for it. You can only use previous information you know to prove the theorem. Once it's proved, you can use it anytime you want. So when I'm looking at this, here's our theorem for a linear pair. Now, guys, is it a two-column proof? Do I have a statement side? And do I have a reason side? Oh, look, I even have a formal, get this, given. Ooh. Now, in a symbolic proof, we call that premise, but when we're in algebra, do we call it given too? Yeah, so we have given. And then we always need to end with our proof statement. I want to show that they add up to 180 degrees. Now, here's why we did the other type of proofs. How should I always start a proof? With a what? How do we always start it? A premise or the word what? We always start with the given. So guess where I want to start? With the given, okay? So I know angle 1 and angle 2 form a linear pair. So that's given. Where in the world did I get this next step? Angle ABC is a straight angle. From the diagram. Awesome. So can I use it if it's in my diagram? Yeah, one thing we can assume for diagrams is straight lines. So we've got that one down. So good. So what is that? Just definition of a straight angle. Now, could I say definition of a line as well? Yes, but you'll see why I'm doing this in a moment. Now, every step has to lead to this. All right, look at step 2, 2, 3. Why in the world did I go from straight angle to the measure of 180 degrees? Yeah, the straight angle equals 180 degrees. See how it just look? Do you think we can do math now? All of a sudden I put numbers in here. I can start doing some math. So this is your reason. The measure of a straight angle is 180 degrees. Huh. Now, I'm not making you do these cold turkey on your own yet. This is hard. We'll get there pretty quickly, but not yet. Look at my reason on the other side. It says the angle addition postulate. Or the sum of the parts equal the whole. What two angles am I going to go with? Owen.
A, B, and then what's the?
I actually use the numbers. It'll be easier.
Oh, angle 1.
Yeah, I'm going to go measure of angle 1 plus the measure of angle 2 equals, can I say, the measure of angle A, B, C? Sum of the parts equal the whole, okay? Now, look what I'm going to say here. Substitution property. What am I going to substitute in? The 180, exactly. So I get the measure of angle 1 plus the measure of angle 2 equals 180. So that's the substitution property. If two angles measures add up to 180, they must be supplementary. So two angles whose measures add up to 180 are, let's abbreviate, supplementary. Can we just say sup is supplementary from here on out? Can we just save time doing that? All right, there's a proof. Does everyone see where the steps come from? It's pretty logical. One step leads to next. Yes, ma'am.
For number 4,
Mm-hmm.
do you have to do that stuff?
Yep.
Right.
Yep, you have to. That's where proofs are a little annoying because in our head, can we normally skip step 4? But in proofs, we have to make sure everyone knows it. It's kind of like doing a recipe. If you don't follow the recipe, you miss something, especially if you're baking. Normally, if you're cooking on the stove, you can survive. But if you're baking, if you miss one step, even though we think it's obvious, what happens? You get a bad batch of cookies. That's why I can't bake well. It's horrible. All right, now we get to do a little bit of math, though, as a result of our theorem. Because remember, the linear pair theorem says they add up to what? 180. So look at this right here, guys. This isn't that bad of a deal. It says find the value of the variables. Well, what would you know right there? What's so special about those two angles? Sum of the parts equal the whole, and aren't those a linear pair? Is this something we've already done before? Yeah, notice I just didn't call it its formal name. That better be 180 degrees. So can I go 6y minus 10 plus 6y plus 10 equals 180? Yay, linear pair theorem. All right, can I simplify? See, we gotta use our formal terms now. Can we simplify now? Yeah, I get 12y is equal to 180. What's y gonna equal, scholars? This is when you're like, Gregerson, that's not fair. That's why you're supposed to have a calculator. It's 15. What, you don't do math in your head like I don't? Come on. Double check me later. You should always check my mathematics. It's kind of like Bible teaching. You should always check to make sure the teacher is saying the right thing and godly things. You should always check my mathematics. Same thing. Lesson of the day. All right, look at the next one. I still need to solve for the variable. Does anyone have an idea how I could do this? Jaden?
Well, if they're, what are they called? Like if they're across from each other.
Vertical angles?
Yes, if they're vertical, that means 4x plus 1 is 65.
All right, you're skipping to Tuesday's lesson. So I'm going to tell you that is a great way of doing it, just not today.
Okay, well.
What's another way?
The other angle is 7x plus 3.
All right, so what about 7x plus 3? What are you going to do with it? There's two different ways of doing this one if we ignore vertical angles.
Wait, so 65 plus 7x plus 3.
Can I do that? A totally linear pair. Good job. So you could go 7x plus 3 plus 65 is equal to 180. And I don't know about you as I simplify on the left side. To me, that would be the easiest way because I don't really want to have to add variables and stuff like that together. But I get 7x is equal to, wasn't it 112? All right, does anyone think they know that one off the top of their head? You're failing me, guys. Come on, help me out. 16, good job. All right, 16. Now, Did any of you think a different way of doing that one? Sophia, what did you do?
4x plus 1 plus 7x plus 3 plus 1.
Yeah, guess what? That's perfectly acceptable. If you show me work, would I give her full credit for this? Because look what happens, guys. I get 11x plus 4 is equal to 180. So 11x is going to equal, what's that, 176? Guess what x still equals? So would I be good either way? Yeah, the cool thing is if you know the linear pair theorem, doesn't matter which one. Now here's the cool thing. If I did what Jaden told me and I skipped ahead because I've kind of given you guys the hint and stuff, they were equal. Guess what it still would equal? 16. I love math. It's so good. All right. So good stuff. You know, it's amazing how factoring can show up in problems like that. Just thought I'd let you know. Okay. You know, square roots. All right, there's two theorems. Guys, this theorem is used all the time, but we forget it because we all know it. Okay? Look at this one. It's called the right angle congruence theorem. Are you ready for the profound moment in your math career? All right angles are congruent. You guys like Gregerson? So boring, okay? Why in the world do I care about that? I have to show congruent angles more often than the fact that they're right angles. So I just have to have a way of saying they're congruent without doing tons and tons of work. It's a time saver theorem. Because think about it. If they're right angles, what do you know? Measure of angle A equals 90. The measure of angle B equals 90. So are they equal to each other? And if two angles have the same measure, are they congruent? It's just so I can state congruency quickly. So when you're stuck and you have two right angles, could we just go there? Okay, could we just say they're congruent? And you can either write out all right angles are congruent, or you can say the right angle congruence theorem. It's almost easier to write all right angles are congruent. All right, now I have two theorems that we're going to do. And we're actually going to prove, actually we're not going to really prove them. But we're going to talk about it because I don't want to spend tons and tons of time doing proofs with you yet. All right, they're really the same theorem. We just changed a couple words. Are you guys ready? The first one's called the congruent supplements theorem. So congruent supplements theorem. Here's what it says. If two angles are supplementary to the same angle or congruent angles, this one has two different ways of actually doing proofs with this, then the two angles are congruent. And here's my question. Why?
Because they're supplementary to the same thing.
Yeah, it's really algebra, right? They're really algebraic. Look at this, what my given is. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. What got repeated? Is it going to change its size? No. If it's 50 degrees, what's the other two angles both have to be? 130. There's actually a nice long formal proof for that. But doesn't that make sense mathematically? It would have to be that way. So we're going to use that. Now look at the name of the next theorem. Congruent what? Complements theorem. Do you think it's the same theorem? What word do I change? To supplementary to what? Yeah, exactly. So if two angles are complementary to the same angle or congruent angles, then the two angles are what, my friends? Let's make our lives easier. Let's use the congruent symbol. Does this make logical sense too, right? Really, we're using the fact that angle 1 and angle 2 add up to 90, angle 2 and angle 3 add up to 90. Oh wait, this is the same angle. So what does that mean 1 and 3 have to be? Congruent. All right. That's your new theorems. Hint of the day. If you want to be good at proofs, you've got to start reviewing your notes daily. That is a #1 thing that's a struggle for geometry advanced students because math comes easy to you. But if you don't remember your past stuff, you're going to get stuck on proofs. And I don't want you getting stuck on proofs. All right. So here's an example of like something you would do from your book. It says, fill in the blanks with the justifications and steps listed to complete the 2-column proof. All right, so these are the ones that are, quote, listed. So these are your only reasons that you have. Look at what the given is, and you guys are going to sit there and go, oh my, this is so easy. Okay, ready? The given, angle 1 and angle 2 are straight angles. prove they're congruent. Does anyone sit there and go, Gregerson, I don't need to prove it. I know they're congruent. That's the problem. You still got to prove it, okay? Just because you know it and it makes common sense to you doesn't mean we don't have to show the step-by-step process how to do it. So looking at this, look at my diagram. Real unprofound diagram, is it? You know, here it is. Ooh, 2 straight angles, or my preference, a line. Okay, a line. All right, so looking at this, what's the very first step? What do we always start proofs with? The given. So what are we going to do then? Start it with given. So that's all you have to do. Angle 1 and angle 2 are straight angles. Given. Now, what do you know about straight angles? They measure 180 degrees. Look what happens next. The measure of angle 1 equals 180, and the measure of angle 2 equals 180. So, what's our reason? Now, I didn't use the definition of straight angles. I don't like that, but you could write that in. I like saying it this way. Straight angles measure what? Doesn't that make more sense in our head? It's almost a conditional statement. If you're a straight angle, then you measure what? 180, isn't it? You can even write it that way if you want to. If you have a straight angle, then it measures 180. I'm good with that. All right, look at the next one. The measure of angle 1 equals the measure of angle 2. Substitution property. If 2 angles are equal in measurement, they must be what? What are they? Congruent. So there we go. So therefore, angle 1 is congruent to angle 2. And remember, this says definition of congruent angles. Here's really what like. Angles with equal measure imply congruent angles, right? Really, it's more of an if then. I like if then way of thinking it. And this year, I'm going to be honest. I'm changing how we write things down because I want to make sure you understand it more than how perfect you write a reason. It just has to be a valid reason on there. Now, homework tonight. You have to do that on one of the problems. Just fill in the gaps. If you struggle seeing it, I would say draw the whole thing out. If you think you could follow along pretty easy with it, I'm okay with you just writing down the blanks in order. Okay? Is that fair? All right, let's look at another one. Oh, lovely proof. I mean, we all are overwhelmed by this. Now, your book tries to be helpful. It says, here's your given. I want to show given angle 1 and angle 2 form a linear pair, and angle 3 and angle 4 form a linear pair. I want to prove that the sum of all 4 angles is 360. Guys, would that actually have to be the case? Yeah, so we know we can get there. Now, look at this. They're going to give you a plan. All right, let's read it through and see if it helps you at all. It says the linear pair theorem shows that angle 1 and angle 2 are supplementary and angle 3 and angle 4 are supplementary. The definition of supplementary angles say that they add up to 180 degrees. Use the addition property of equality to make the conclusion. Now, in your book, they're going to give you plans sometime. If it's helpful, use it. If not, I could care less if you look at it or not. I want you just to be able to do the proof. So here, again, I'm giving you a start because I feel like this isn't really fair to make you go completely on your own yet. So look at the very first step. I still have my statement side. I still have my reason side. Oh, what's the first step always going to be? Given. All right, given. Check, given used. Now look at the very next one. It says angle 1 and angle 2 are supplementary and angle 3 and angle 4 are supplementary. Isn't that the linear pair theorem? Wasn't that we just talked at the beginning of class? Yeah. So you could either write, here's my 2 reasons I take. Linear pair theorem, or you could do this. The linear pair implies supplementary what? Angles. One or the other. I'll take either as valid reasons because aren't they really the same thing? All right, now look at the next one. Number 2. If they're supplementary, what do I know? To be honest, if I was writing this one from scratch, we wouldn't have done the second step. We'd have gone straight to step 3 because how I define the linear pair, you should know supplementary angles add up to 180. But we're going to go. I can see how they do this. And that's because supplementary angles are two angles that add up to 180. And look at the very last one. If I add the same thing to both sides of the equation, is it still true? So guess what I'm adding? You could say I'm adding the measure of angle 3 plus the measure of angle 4 to the left and 180 to the what? Could we, okay, in our brains, could we even say this? Right? So isn't that just the addition property? Oh, yeah. All right. Do you guys see how geometric proofs are harder than the ones we've done so far? But I don't expect you to get it the first time around. All right? I expect this to take some time. Kind of like Sherlock Holmes packet. Did you get it the first time around? No. But when we're done with direct proofs, all of a sudden the laws made sense. It takes time. Sometimes we have to struggle with it. So how about we do this one from scratch? Let's do one from scratch. Few things. If a theorem ever has a name, know it, because it means it's supposed to give you a shortcut for writing it for proofs. Some of you are like, I am completely overwhelmed when there is a proof with nothing in it. Don't worry, you're fine. Remember, I'm standing right here. I can help you guys do this. But I want you to see how we do this all from scratch without our hands being held, okay? So, guys, look what I have. You always ask, what do I have? The sum of the angles measures in a triangle is 180. Is that anything earth-shattering new to you? We actually will prove it. We'll actually know why it actually works this year. We're going to prove that the measure of angle 1, this angle on the outside right here, these two add up to it. That's what we're going to try to prove. Now, are you guys ready? Where do we start? Given. All right. So let's do that. Let's write it down. The sum of the angle measures of a triangle is 180 degrees. Given. Now, what does that tell you? I have to use that to get to my next step. What do I know about the measure of angle 2, the measure of angle 3, and the measure of angle 4? They add up to 180. Right on. So look for step 2 here. Look, common sense. Measure of angle 1, not 1, excuse me. I can take it back to 2, sorry. Measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. How do I know this? Really, didn't that come from step 1? Can we just say the angles of a triangle add up to 180? And if we're really doing this, I should probably say the measures. That's stuff for you how to spell it correctly. Make that. We probably should say the measures of the angles of a triangle add up to 180. Aren't we just using our previous information to get where I need to go? All right, what do you guys think next? It looks like we're stuck a little bit, right? What do you guys think? Are we stuck? Guess what? If you're stuck, do you have this thing called the diagram? Is the diagram given to you? Look at the diagram and look carefully at 1 and 2. What are those? Not supplementary. I can't go there instantly. I have to say they're what first? They're a linear pair. Oh, excellent. So that's what you're going to say next. For step 3, you go angle 1 and angle 2 are a linear pair. Those of you who said supplementary, guess what my next step is going to be? That step. So how do I know this? Isn't that really the definition of a linear pair? And can I just say diagram there so we all know that's where I got it? You don't have to put the word diagram there, but when you're stuck, a lot of times the diagram is where it comes and saves the day. Now, what I like about this, you guys did a good job with this, is you already told me what to do next. What do they add up to? 180. Beautiful. So that's what I'm going to do next. Step 4, I'm going to go with what logically happens. Because if they're a linear pair, I know they're supplementary. So the measure of angle 1 plus the measure of angle 2 equals 180. Can I call that the linear pair theorem? What would be another way of writing this and getting them full credit? Could you go, not some of the parts equal whole, but can I say linear pair implies sup angles? Would that be true? Is that really a shortcut way of writing out the whole long theorem? Guys, either one of those I would take. All right, now, notice, have I used step 2 yet? Have we used step 2 yet? Is there any way I can use step 2 and step 4 together? Substitution. Guys, if they're both equal to 180, can I use that as for substitution? So could I say this? The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus, I'm going to go a little bit over, plus measure angle 3 plus the measure of angle 4. I know I went into the other line, sorry. Is that true? Yeah, and that's just the substitution property. I can't spell substitution all of a sudden. Now remember, go back to what we're looking for. We're trying to show the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. What don't I want? I don't want angle 2. How can I get rid of angle 2? Emma. Thank you. If I subtract the same thing from both sides, does it go away? So guess what I'm going to subtract from both sides? The measure of angle 2. Look at this, guys. We're at our therefore statement. The measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. That's just using the subtraction property. Do you see why now I had to review algebra? I still have to know the geometry, but I end up doing algebra a lot in my proofs. A 6-step proof. Do I expect you to do a geometric six-step proof on your own? No. Would I expect you to do an algebraic one? Yes. Would I expect you to be able to do a direct proof? Yes. Geometry? You're not there yet. Okay? You're not there yet. Do I want you to try and mess up? Okay, I know that's mean, isn't it? I want you to try and make mistakes and get it wrong better than not to try at all. So here's a few things I want to remind you about this stuff, okay? If your book ever says to do a paragraph proof or a flowchart proof, you will ignore those directions. You will only do 2-column proofs. You can use the book's paragraph proof or flowchart proof to help you get a 2-column proof, but I will never, ever, 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 ever ask you to write it that way. A paragraph proof is taking a 2-column proof and putting it in sentences. This is good enough, okay? This is good enough. Also, you must, okay, always show me the T. All right, you have to have a statement sides and a reason sides. Is that clear? You always have to do that. Also, here's one way to get a point if you're stuck. Are you ready? At the very end, let's just say I'm here at the end number. If you don't stop with the proof, you did something wrong. Okay? Always end with the proof of a proof. Kind of like the same thing. If I was doing it with direct, the symbolic proofs, if we didn't end with the conclusion, did we get to the conclusion? No. So we're always going to get there. Also, think about it. If stuck, go to the diagram. Because here's our things you can get. From diagrams, you can get linear pairs. From diagrams, you can get vertical angles. From diagrams, do I know adjacency? You can assume straight lines. This will give you lots of stuff to do, because remember, if I have a straight line, is that a straight angle so I can get 180 degrees? So if stuck, we always go back, all right? Or you go back to other givens. This case, we only really had one set of givens. Do you think I might have more givens than one? Yeah, did we have more premises than just one when we did symbolic proofs? Yeah. So those are the type of things that are going to help you out. Now, what's the best way of doing proofs? Struggling it and trying them. Guys, you actually have time to do homework. Get to it.